everybody. We're on 5.5, second to last lesson of Calculus 12. So derivatives of bases other than e, so we're looking at things that look like this: 2 to the power of x, 5 to the power of cos x, things like that. We're going to derive the formula here. So if I have y is equal to a to the u is some function of x, all right? Either x, cos x, x cubed plus 1, whatever, it doesn't matter. So whenever I have an exponent that is a variable, so an exponential function, other than e to the x, I natural log both sides. So I end up with the natural log of y is equal to the natural log of a to the u. And the reason you want to natural log it is because the u will fall down, and I get that. Now I can derive it. So the derivative of natural log of y will be y prime over y, u primed over u. You're doing natural log of u. On this side, a is a constant. It's our base. So it's like the 2 or the 5. So you don't worry about that. So really all you have to derive is the u, which is just u prime times the natural log of a. And then we want y prime, so I multiply my y up. I get that. What was y? It was a to the u. So I get a to the power of u primed, natural log of a. That is your formula for the derivative. You can remember that if you want. I never do. I just basically natural log the function and do the derivative. The other types that you're going to see are log functions. So first type we're going to see is stuff like that. Second type of function that we're going to see that we haven't looked at is when you're asked to derive a log other than a natural log. What do you do? So here's our generic. So we don't know how to derive a log function that isn't a natural log. So what do? We change the base. And we change it to a natural log function. So if you don't remember change a base rule, you can look it up. Well, I'm going to write it here, but if you need to practice it, you can look it up. But it says, if you have log base b of a, I can change the base from b to anything I want. I'll just call it c of the argument over log of the new base c of the argument of the original. So if you're doing natural log, it'd be natural log of a over natural log of b, which is what we're going to do here. We're going to change this log base a of x to derivative of the natural log of x over the natural log of a, which makes our life a whole lot easier because natural log of a is a constant. You pull constants out of the derivative. So really you're just deriving the natural log of x, which is just 1 over x. That's it. So you can get to the same spot if you do it with a u function. I'm not going to do it, but log base a of u, you're going to change it to natural log of u over natural log of a. Again, the 1 over natural log of a gets pulled out as we did here. So really the derivative of the natural log of u is u primed over u. So we get 1 over the natural log of a times u primed over u. Clean that up, be this. Again, you can remember the formulas if you want. I find it easier just to use natural log each side in the equation. So our examples. Example number 1. I have y is equal to 2 to the power of 3x. What I do, as soon as I see a variable in the exponent, I natural log the whole thing. I do a natural log of y. If I natural log it, the 3x falls down. So I get 3x natural log of 2. natural log of y. Now derive it. So derive this, both sides. So I get y primed over y is equal to, natural log of 2 is a constant. Derivative of x is just 1, so it's 3. So it's 3 natural log of 2. Multiply up the y. And what was y? It's x. So it's 2, 3 to the x times 3 natural log of 2. If you want to clean this up a bit, the 3 can become the exponent on the 2, so that's 2 cubed, so it's 8. So it would be 2 to the power of 3x natural log of 8. Excuse me. All right, number 2. Y is equal to log base 10 of cosine x. Okay, it's a log that is not a natural log, so you need to change it. So we're going to rewrite it as y is equal to the natural log of cos x over the natural log of 10, and then derive. So um, I'm going to get, so this is just a natural log function now. I can simple regular one, like I can pull out the natural log, 1 over natural log of 10 times the natural log of cos x. So dy dx, I don't even have to do what I did up here and natural log everything. So dy dx is 1 over the natural log of 10 times derivative of natural log cos x is over cos x, and up top goes the derivative of cos x, which is negative sine x. Now you could leave it like that, or you could recognize sine x over cos x is tan. So I get negative tan of x over the natural log of 10. And that's dy dx, or y primed. All right. Excuse me. Number 3. Y is equal to 3 to the 2t over t. Now this function looks a little more complex because we have a quotient rule problem, a function in the numerator, a function in the denominator, and the function in the numerator is an exponential function, which I don't really want other than e. So it's going to get quite tricky. But if you remember your log rules, logging things helps, and we always natural log. So if I natural log both sides, I get this, which then allows me to break up this side. We're dividing, so I can subtract them, and I can drop 2t down, so I get natural log of y is equal to 2t natural log of 3 minus natural log of t. Then I derive it at this point. The derivative of natural log of y primed over y is equal to the derivative of 2t natural log of 3, constant, derivative of t is 1, so it just becomes 2 natural log of 3, or natural log of 3, sorry, minus derivative of natural log of t is 1 over t. Multiply the y up. What was y? It's this thing. So y prime is equal to 3 to the power of 2t over t times, I'm going to move that 2 up, 3 squared is 9. So we have natural log of 9 minus 1 over t. And there you go, you're done. All right, we have one more example. So for y is equal to log base 3 root x over x plus 5. So first thing, let's get rid of the square root because we don't like those. So it's log base 3 x to the 1/2 over x plus 5. And because we're logging it, we can subtract them because they're being divided. So this is actually log base 3 of x to the 1/2 minus log base 3 of x plus 5. Again, logs allow us to drop that down, which is a good thing. We get 1/2 log base 3 of x minus log base 3 of x plus 5. Y is equal to all that. Now, that's the setup. Now I don't want to derive log base 3 of x. I want to change the base. So I change it to natural log. So it's natural log of x over natural log of 3 minus natural log of x plus 5 over natural log of 3. And now at this point, I can derive it. But what you need to remember is that all of that is a constant. Those are numbers. Who cares? So really, I'm just deriving natural log of x, which is just 1 over x. So y prime becomes 1 over 2 natural log of 3x minus, remember, there's a 1 there, pretend. 1 over natural log of 3 is a constant, so I'm deriving natural log of x plus 5, which is 1 over x plus 5. So I get 1 over natural log of 3 times x plus 5. And I guess I should make it clear that this is 2 natural log of 3 times x. It's not 3x. At 2, if you could leave it like that. You could clean it up a bit. You could I could factor out a 1 over natural log of 3. And I'm left with 1 over 2x minus 1 over x plus 5. I'm going to make a common denominator. So I'm going to get x plus 5 minus 2x all over 2x times x plus 5. Clean up the top. X minus 2x is negative x. So I get 5 minus x over 2x, x plus 5. You can dump the 2x in if you wanted. You can basically take away the brackets because it's 1 times the top and natural log of 3 times the bottom. So we look like, excuse me, natural log of 3 times 2x times x plus 5. You don't have to do this. You can stop it there. All right, everybody. I hope that was okay. Really, this is just practice with logs again. If you have a base other than, it's not a natural log, and it looks like something like this, where you'd have to use quotient rule, chain rule, all these different things, use the fact that it's a log to separate it out and change it to natural logs. You always want to change to natural logs. If you have something that is a bit more complicated, it's going to involve quotient rule and an exponential. Log both sides again to allow yourself to break it up and then derive it. And if it's even if it's a simple one, I don't remember the formulas up here. I don't remember any of these. You can figure them out just by natural logging everything. So I would just natural log both sides and then derive. Just remember when you do it, the natural log, derivative of natural log of y is y prime over y, and you have to multiply that y up. And remember what the original y was. That. Okay. Questions are page 362, numbers 37 to 69 odd. Best of luck, people.